any waste of time. I understand it is Friday and worse for us teachers in the Free State. It is month end today. So like to start with the discussion right away. And then before we start with the content of the guideline, I just want to refer colleagues to the marking guideline session that we had with Mem Manchu on Wednesday. It was a very informative marking guideline, especially when it comes to the principles of marking. So I'll urge colleagues to please go on YouTube and listen to the marking guideline, especially the first part where Mem Manchu is dealing with the marking principles. It is important that colleagues do that because we have since realized that the marking standards, especially at schools, have deteriorated, colleagues, since we are now in the process of moderations. So please, colleagues, go back to watch the marking guideline session that was led by Mem Manchu, and focus should be on the first part where she was explaining the marking principles for both paper 1 and paper 2. Those are very, very important so that we improve, colleagues, our marking quality and standard. We are very concerned with the standard of marking of our teachers at schools. So please refer to that session and then do as requested, colleagues. Another issue as we are going through the moderations, colleagues, what we have realized is that there are colleagues who deviate from the assessment guideline. Colleagues will choose not to write the provincial test. Some will write the provincial test, but then remove some of the questions from the question paper. And then that deviation from the assessment guideline is not accompanied by any sort of documentation or permission from the district office. Colleagues, we are urged that for whatever reason, if one sought to deviate from the assessment guideline, or maybe they do not wish to write for whatever reason, or they can't write the provincially set SBA task, colleagues must sought permission from the district office and evidence thereof of approval for deviation must accompany our SBA files as we send them to the moderation processes, and also as colleagues visit schools. That evidence of one asking for permission, wherein schools will state reasons for their request to deviate, and also the permission from the district office. That evidence must be readily available should there be a need for us to confirm. But we are concerned with colleagues not having evidence of one asking for permission and also getting the permission to deviate. Colleagues, then the papers that then colleagues write, we find they are not of good standard. They have deviated from, they chose not to write the provincially set paper, but then the papers that they administer are not of good standard. Then that becomes a problem. So the first thing, colleagues, let us get permission from the district office for deviation. And in the permission, we must state reasons as to why we wish to deviate. And that must be in writing. And evidence thereof must always accompany the SBA files. And then another one that I also want to highlight, colleagues, is the issue of remediation of SBA task. Colleagues, let us please remediate the SBA task with our learners. What we see is that for some schools, it becomes worse because you'll even recognize that learners were not given these scripts back so that they see their mistakes. So please, colleagues, after marking, let us take the scripts back to learners. Let us remediate this SBA task with our learners. Why do we see instances, or why do we come to a conclusion that learners might not have might not have seen the scripts is simple mistakes as counting, simple mistakes on wrong or incorrect marking on multiple choice. We still come across those. And we know for such things, if a learner had their scripts and then these things were remediated with them, such mistakes will not be there. Learners will be able to correct such mistakes with their teachers. So we are requesting colleagues, or learners must see their scripts, and we must also remediate the SBA tasks with our learners. And I'm sure you'll have seen, if you look at grade 11 and grade 10 papers of June, if thorough remediation of those papers was done with our learners, we'll expect our learners to perform very well in June now. Because many of the questions, it might not be exactly the same, but then they they will have prepared learners thoroughly for our June examination papers. So please, colleagues, let us remediate and ensure our learners see their SBA tasks after Monkey. Those are the things that I wanted to highlight before we get to the discussion. Now, colleagues, as I indicated, earlier, we'd like to start right away with our discussion. From our side, we did not receive any concerns with the paper from question 1 up to the last question. So in terms of the technicalities and maybe the mistakes, I'll take it to colleagues are okay in terms of those with our paper. Therefore, we'll then get straight to the discussion. For question 1, colleagues, we did not receive, like I indicated, any concerns with any question. And then I would like to move that we take the answers as are from the marking guideline, unless colleagues have any concern with any questions. If you have any concern with any question on the multiple choice, this is a chance that you'll then raise your hand, colleagues, and then raise your concern. But we did not receive anything. And for that reason, I would like to move that we accept the answers as given in the marking guideline. Let us not forget to complete the attendance register. I believe it is shared in the chat, and also it was part of the links that were shared with the link of this marking guideline. Colleagues, any concerns for question 1? If there are no concerns, may I please get an indication just with an emoji of a sharp? Then we move on to question 2. I saw an emoji of a sharp. I believe colleagues are okay with question 1. Then colleagues, let us move on to question number 2. I will not display the question paper. I'll be reading the question paper from the hard copy that I have here. What I will be displaying there, it is the marking guideline. So with question 2, that is, the focus was on Newton's laws. We have 2 blocks, A and B, of masses, of mass 6 and 3 kilograms respectively, that are in contact with each other on an inclined plane. We have a diagram there. Then a force F applied parallel to the incline causes the blocks to accelerate up an incline at 2 meters per second squared. Then the first question, learners were asked to define the term normal force. So here, colleagues, it is not 2 or 0 question, but context is very, very important. The definition as taken from the examination guideline says that normal force is the force or a component of the force which a surface exerts on an object with which it is in contact and which is perpendicular to the surface. So the marking criteria there is that we'll subtract 1 mark for the omission of one of the key words of phrases. keywords or phrases are the ones that are underlined. If any of the underlined keywords or phrases is omitted or are omitted, but in correct context, meaning the definition still makes sense, colleagues. It must still make sense. For instance, if a learner omits a force as an example, but then goes on to say which acts parallel to the surface, then the context is now lost. Then the learner will lose everything. I hope colleagues get what I'm saying. Or maybe surface also is not there. Then it is exerted by another object in contact with it, not specific to the surface. Then the whole definition loses context. And once the whole definition loses context, whilst one of the key words or phrases has been omitted, then the learner will get 0. But if one is omitted and the context is still there, then that learner can get 1 out of 2. I'll make an example. A force which is exerted on an object which is in contact with it and which acts perpendicular to the surface. That part of it being exerted by the surface maybe is not there. But if you read it in as a whole, then the definition still makes sense. Then in that case, that learner will get 1 out of 2, not 0. I hope colleagues get what I am saying. We just have to read through. But if the learner then takes it out of context and also they have omitted keywords, then they will get 0 out of 2. That is how we will mark question 2.1, which is a definition for normal force. Then 2.2, I'm just making examples, colleagues, but then as a science teacher, as you read the definition, you must be able to check as to whether it makes sense or not. If it does not make sense, then that learner will get 0. 2.2, the magnitude of the kinetic frictional force acting on blocks A and B is 6 newtons and 3.4 newtons respectively. Then 2.2, learners were asked to draw a labeled free body diagram showing all the forces acting on block B as it moves up the inclined plane. So we are expecting 4 forces there, colleagues. The first force is gravitational force. The second force will be the normal force, which must be perpendicular to the surface. The third force will be the frictional force. And because it is moving, then it must be kinetic frictional force. And the fourth force will be the force that block A exert on block B. Hence, they label their colleagues. The force that block A exert on block B. Those are the forces that will be acting on block B as it moves up the incline. For acceptable labels for each force, for normal force, we can accept the capital letter N, we can accept normal, or we can accept if a learner writes it in full and says normal force. For kinetic frictional force, these are the acceptable labels. We can accept capital letter with a subscript small letter f, capital letter F with a small letter f as a subscript, small letter f acceptable, fr acceptable, fw for Afrikaans, it is also acceptable, or the learner can write it in full and say frictional force or kinetic frictional force. That we can accept. What we will not accept, colleagues, is if a learner writes fs. If a learner writes fs or fs maximum, then the learner is talking about static frictional force. That we will not accept for frictional force. Then for gravitational force, we can accept small letter w, and it must be small letter, colleagues. We can accept mg, weight in full. We can accept force of F on B. We can accept the magnitude of the gravitational force, which is 29.4 newtons. A gravitational force as a whole. Those are the labels that we can accept for gravitational force. And then for the force that block A exact on block B, we have decided to accept applied force since it is the force that is applied by A on B. And then that will be capital letter F, FA, or applied force. So we can accept for FAB, we can accept applied force for that, colleagues. That is for 2.2. And then question 2.3, then learners were asked to calculate the following. The first one, 2.3.1, they were asked to calculate the normal force on block A. Normal force because it is on an inclined plane. We know normal force is equal to the perpendicular components of the gravitational force. That will then be the mass of block A multiplied by 9.8 and then cos of the inclined plane. Then the answer that we get there, it is 50.92. So the mark will not have a mark on the formula. The mark will be on the substitution and then the final answer with units. And because they were asked to calculate only the magnitude, so the learner does not have to indicate direction there. So the 2 marks is on the substitution and the final answer with the units. 2.3.2, then learners were asked to calculate the magnitude of the force F as the system moves up the inclined plane at 2 meters per second squared. So we have 2 options for that. We'll use, or learners were expected to use Newton's second law to solve this problem. So for option 1, where up the incline is taken as positive, learners will then have to consider block B. And for block B, they will then look at Newton's second law based on B, that will be F net is equals to MA. And then from there, looking at the forces that are acting on block B parallel to the incline, we'll have the force that A exact on B minus the frictional force on block B minus the parallel components of the gravitational force on B. And then that will be equal to the mass of B multiplied by the acceleration of block B, which is the acceleration of the system. Then learners will then get the answer for the force that A exact on B, which must be 24.1. But learners must then see, or they must know that this force AB, is equals to force BA, but in an opposite direction. Now, when they consider block A and then still apply the same principle, which is Newton's second law, they will then end up with 4 forces acting on block B parallel, or on block A parallel to the incline. It will be the applied force. And our learners must also know applied force is a contact force, and with the diagram given there, applied force is applied on block A, not on block B. So we'll have applied force acting there, we'll have frictional force, FG parallel, and the force that B exact on A. Then we'll have F minus 6.8 minus 6 times 10 to power 9.8 sine of 30 minus 24 taken from the earlier part, which is calculation for, or when we were dealing with block B, and then equating that to 6 times 10 to power 2. Then if that is done correctly, the answer should be 72.3 newtons. So how then do we allocate the mark? The mark will be on the formula for Newton's second law. Either one will get a mark, colleagues. The learner does not have to have both of them. If the learner has got 1, then we'll give a mark. The second mark will be on either one of the substitutions on the right-hand side. For block A or for block B, that mark will be on 3 times 10 to power 2. or this mark can be placed if the learner considered block A, wherein we have 6 times 2. On either one of the substitutions, then a learner will get 1 mark. And then the third mark on block B, the substitution on the left-hand side of frictional force and FG parallel. The whole substitution with the correct signs must be minus and minus. If that is the case, then a learner will get 1 mark. Then the fourth mark will be on the correct substitution of the forces acting on block A. That will be on the left-hand side of the equal sign. With correct signs, colleagues, meaning 6.8, 6 times 9.8 sine 30, lead 24, comma 1. They must all have the same sign. If the learner has done that and has done that correctly, then a learner will get the 4th mark, and the 5th mark will be on the final answer. That is how we allocate the mark for question 2.3.2. And also consider the correct transference of this 24.1 taken from block B to the calculation for block A. So it means, or if a learner gets it here as positive, then here they will substitute it as negative, and that will be seen when you look at the second option. If the learner gets it as negative here, then we expect them to get to substitute it here as positive, because the two are moving in opposite directions. So that is the mark allocation for 2.3.2, option 1, where we have taken up the incline as positive. Then option 1, then option 2, where we have taken up the incline as negative. It is just but the change of the signs, colleagues. So we'll have, for block A, instead of the minuses there, we'll now have what? We'll now have the plus. But the principles that we have explained earlier, then they must be the same. And then maybe what will help also is, you see, if we have the negative signs on the left-hand side for the forces, then the acceleration must be positive, because the forces are moving down the incline, but the acceleration is moving up the incline. So acceleration and the forces must not have the same signs. If these ones on this side are positive, and then this one must be negative. Let us just be careful of that, colleagues. And also remember, as discussed in the principles of marking, once a learner loses a mark in the substitution, then the answer cannot be correct. So option B, just no, option 2, it is just a change in the signs. So instead of a negative here, we'll have a plus, because now we have taken down as positive, and then because up the incline is taken as negative, then our acceleration must be negative. And then that will be the same for block A and block B, the change of the signs. But please be careful, colleagues. Please be careful. If a learner uses option 2 to do this thing, then the learner must first get his or her applied force. Must get his or her applied force as negative first, because that is what the calculation is, or will lead to. The learner with option 2 cannot go straight to a positive value for F. It is very, very important. If a calculation leads to the first negative answer, then the learner must show us that negative answer and then interpret the negative answer after that. So I hope colleagues understand what I am saying. It is very, very important, colleagues. If the answer leads to a negative answer, then the learner must show the negative answer first, and thereafter they can then conclude on their answer and then write it as positive, because we are looking for the magnitude. So please be careful, especially if a learner uses option number 2. The note for this is, if one system of blocks is used, wherein a learner now combines the masses, and then they will have a 9 there, instead of 6 and 3 separate, and then they will have these forces of FA and FB subtracting each other, and here for F6 times 10 FG parallel, then they will have 1 FG parallel, and then maybe even the frictional force, they will have 1 frictional force. If a learner chooses to do that, we said we will then have a maximum of 6 marks for that learner. But please, colleagues, let us teach our learners to deal with these blocks separately. This, it has been coming a lot of times, and our learners are losing a mark because of using one system when they have a situation such as this. They must deal with these things separately. So the 3 out of 6 marks will be on one formula, correct substitution. The whole substitution must be correct, and the correct final answer. Then we will then give a learner 3 out of 6 as the maximum if the learner uses one system of blocks. That is that for question 2.3.2. And then moving on to question number 2.4. Then here learners were told that the angle of the incline and the horizontal is changed to 20 degrees. Now the angle of the inclined plane is decreased to 20 degrees. That is what has happened. Then learners are then asked, how will this change affect the magnitude of the kinetic frictional force acting on block B? So what has been changed here is the angle. The learners must recognize what the independent variable is the angle, and how does the angle then influence the normal force, but not the normal force first, but then the frictional force. Then the learners must then be able to relate frictional force and the changes in the in the angle. So the answer should be increases. Reason being, if the angle of inclination decreases, then FG perpendicular will increase. Then according to the formula, Fk is equals to mu k normal force. For constant mu k, if n increases, then Fk also increases. And please note what is underlined there, colleagues. Those parts that are underlined are key. They must be there. So these other ones, they may be omitted, but the underlined ones, then the learner must refer to them. So please, colleagues, just check if learners have mentioned or made reference to the underlined parts. And you see here with the formula Fk is equals to mu k normal force. It does not go alone. It must go with the fact that constant mu k. The fact that mu k is constant, it must be in the explanation, colleagues. So the 2 marks will be for the first part, where the learner says that Fg perpendicular increases, and we know Fg perpendicular is proportional to the normal force. And then if Fg perpendicular increases, then the normal force will also increase. And when normal force increases according to this formula, Fk will also increase, given that mu k is kept constant. So that is that for question number 2. I will then open colleagues for hands, for clarity, and maybe additions. I see the hand of Mema Lasela. You can unmute Mema Lasela. Thank you very much. Do you want to come now, or should we allow Mr. Mugwe?
No, it's fine. It is just a suggestion on 232.
Okay, ma'am.
Yeah, I suggest that we give 2 out of 5 for system method if it is used. 1 mark for the formula and only 1 mark for the final answer, not 3 out of 6.
All right, Ma'am Alatela, I think we should take it so that it serves as a deterrent. Or learners must not be doing this thing, colleagues. I think we have been saying this for quite some time. And then if one could be harsh, we'll even say, let us not give it, but let us give 2. I agree, Ma'am Alatela. We'll then move it to 2. Colleagues, please note, system method, we have just agreed or we'll give it 2 out of 3. 1 for formula and 1 for final answer. Thank you very much. Thabo. Mr. Mukwege.
Yes, Meneer.
Yes, Meneer.
Meneer, I wanted to ask, can you scroll down to 2.4.2?
Okay.
Yes, Meneer. I wanted to ask, Meneer, if Elena says, according to FK is equals to mu K N for the same coefficient of friction, decrease in the angle of inclination, decreases the what is this, the normal force, or decreases the perpendicular component of weight, and the normal force decreases. And then they talk, and then they mention that normal force is directly proportional to the perpendicular component of weight. Should we award 3 marks also in that instance?
Do I hear you correctly saying decreases?
No.
Or
Oh no,
said,
the decrease was a mistake. Increases.
okay. It increases. Yeah.
Yes.
Yeah, from what we have said, I think it is correct. But I think they will have responded to what happens to the frictional force in 2.4.1, which is increases. Ne? That is why that is why this part of normal force and FK is not necessarily given a mark. Yeah, Minir, I think we'll get that learner will get full marks. I was just worried about the decrease that you referred to.
Oh,
okay.
No, that was a mistake.
Okay, sharp, Minir. Thank you very much. Mema Lasela?
And Tata MOHAPI, back to 232 again. There's a new trend on marking the substitution for MA. Ne?
Okay.
So because we have 2 blocks of which learners are expected to do the calculations simultaneously. So now learners will get 1 mark for both substitution, not any one of them. So if learner opted to use only block B and then did not show any calculation on block A, then that learner will forfeit the mark for substitution of MA. So now, because it's a new trend and then it's going to start now in June, so I suggest that we give 1 mark for both substitutions are MA, for both block A and block B.
Okay, Mema Lasela. Yeah. Can we benefit because it's new, but then it's fine then. Okay. Colleagues, there is another suggestion. Yeah, but the correct sign says that a learner must use both of them. So the learner can't use one once they have 2. Okay. Another change, colleagues, on 2.3.2. It will then mean, or for the substitution on the right-hand side, we'll then take both of them. Once both of them are there, is then when we can give a mark. But if a learner chooses to use only 1 block, then it means they will not get that mark. Okay, that is that for question number 2. I do not see any other hand. I do not know, Mema Lasela, if there are hands in the, or other questions in the chat.
On the chat, we have Tatemaile saying 242, Elena wrote normal forces increases with a decrease in theta, according to FK equals to U mu K normal. F is directly proportional to normal force. Do we award full marks or 1 out of 2? So which means the learner did not indicate that mu K is constant, just indicated the relationship between friction and normal force.
No, that constant mu K, we want it. And also the first part, I did not hear the learner relating normal force with FG perpendicular. They just say when normal force increases, then, or when the angle increases, then, oh yes, when the angle decreases, then normal force increases.
Yes.
But how? Yeah, you get that relation, Leona, is important for me.
Okay.
Yeah.
So we'll get 0 Ntate Meile, 0.
Yeah. Okay.
So that is all from the chart.
Okay. Then if that is all from the chat, colleagues, can we then move on to question number 3? Just note the changes that we have made. We said if a learner uses the system here, then the learner will get 2 out of 6. And then here, as advised, colleagues, so that our learners get to know this new marking trends. For this mark here, then the learner, it will this mark will be for both substitutions, for both 3 times 2 or times 3, negative 2, and 6 times 2 or 6 times negative 2. Both of them must be shown and must be correct for a learner to get this mark. So that will be a change that will come with the updated memo. And then moving on to question number 3, Mr. Tekiso, before we move, we can't hear you, Menier. Tekiso, you are muted. Oh, okay. No. I take it over your China. Then question number 3. That is on vertical projectile motion. And then the question was asked in the form of a graph. First, or the question says, a learner studies the motion of a ball and draws a velocity time graph as shown below. The learner studies the motion of a ball and draws a velocity versus time graph as shown below. He drew it few moments after a ball was projected from a high platform. So the learner did not draw it immediately as the motion of the ball started. So that learner drew it for few moments after it was projected. And then the ball has a mass of 150 grams and bounces several times, as can be seen from the graph. Now learners were told to ignore the effects of air resistance, and that then means that the ball is in free fall, or that ball is a projectile. First question, define the term projectile. This one, colleagues, 2 or 0. It must be given as given there. Anything missing, then it becomes wrong. Motion with which the only force acting on an object, on the object, is gravitational force. Very, very important that learners give it as it appears there. Then the second question, 3.2, was the ball initially projected upwards or downwards? Looking at the graph, colleagues, the initial motion of the object was downwards. Reason being, velocity of the object increases. Learners must say velocity of the object increases. Initially, because it was said initially projected upwards or downwards. So initially it was projected downwards since the velocity of the object increases. And that is how we should teach our learners. It increases because a projectile, its acceleration is downwards. That is why when it goes down, its velocity increases. But when it goes up, its velocity decreases because acceleration it is downwards. So those are some of the things that we need to highlight to our learners. And then 3.3, Mezongola, you are noted. We'll take hands after the question, unless it is an agent thing.
Mr. Mohapi, 3.1.
Can we take questions after we are done with the whole question, ma'am? I thought maybe it is something that is very urgent.
Okay.
Once we are done with question 3, then we'll take questions, Ms. Ongola. You can mute now, you are noted. Thank you very much. And then 3.3, learners were asked to determine the magnitude of velocity, initial velocity of the ball. Learners were asked to determine the magnitude of initial velocity of the ball. So here a learner, through their understanding that the acceleration represents or rather the gradient represent the acceleration in a velocity versus time graph, they can choose to use this formula to do that. And with that formula, they can use the points of 0 and initial velocity and also 1 and 19.84, because those points were given in the question paper. With that and 9.8 as the acceleration, then the learners will then be able to get their initial velocity, and they must get 10.04 meters per second. The learners can choose to use gradient, and with gradient, they can use the first part of the motion, acceleration 9.8, since it is a projectile in free, or rather an object in free fall, and then using the points there, 19.84 and 1, and initial velocity that we are looking for and 0, then that should lead to 10.04 meters per second. And also, second option, a learner can use equations of motion, but please note already no marks for the formula. With equations of motion, the learner can have initial velocity, final velocity as 19.84. Initial velocity is what we are looking for. Then 9.8, then the time is 1. Then that will lead to 10.4 meters per second also. And I hope we do not get this, but if it happens that the learner, since they have a graph, they then extrapolate to the velocity axis, then they get 10.04 as their answer from extrapolating on the graph. Then let us accept 10.04 meters per second, and then take it where a learner has extrapolated the graph to cut the velocity axis. And if they do that accurately, they must get 10.04. If you look at the scale, colleagues. So, but because of printing, we then said for this option number 3, let us have the range from 10 to 10.06. That is question number 3.3. We then move on, colleagues, to question 3.4. Then on 3.4, for the first bounce, learners were asked to calculate the impulse on the ball. For the first bounce, learners were asked to calculate the impulse on the ball. Remember, the impulse has to do with collision, meaning learners must concentrate at the point of contact, and they must realize already the velocity that the ball will hit the ground with is their initial velocity, and the final velocity will be the velocity with which the ball will leave the ground with. So the changes in velocity must be concentrated there at the point of contact. Initial being the one it hits with, and final being one it leaves with. That is something that many of our learners miss when it comes to the impulse question. So impulse, as according to the formula, is given by F net delta T, or change in momentum, or M into final velocity minus initial velocity. So any of those formulas, colleagues, let us give 1. And then the second mark will be for the correct substitution. The whole substitution must be correct, which is 0.45, because the mass was given there in grams. The learners must convert it to kilograms. That is division by 1,000. Then it will be 0.45. And then into the velocity, which is 11.27, it is an upward velocity. And learners must also realize, or from the given graph, downwards has been taken as positive. So this upward velocity, which is 11.27, it is the velocity it will go up with after the bounce. So it must be negative. Then minus 19.84, which will be the velocity it hits the ground with. And then the first answer, as indicated earlier, because the calculation leads to a negative answer, colleagues, then the learners must show us the answer really negative. Then they can then interpret the thereafter. So if a learner from here, from this part, they then go straight to impulse is equal to that, then that learner will forfeit 1 mark, because the calculation with the negative signs does not lead to a positive answer. And it is something that we need to indicate to our learners, or they must get it as negative first and then interpret thereafter. So the correct answer for impulse there must be 14 newtons second upwards, because impulse is a vector quantity. It must have magnitude and direction. So option number 2, we will accept if a learner takes down as negative, but from the graph, colleagues, it is clear or a down is positive. But if a learner takes down as negative, let us accept it. And then that will then lead to this 11.27 being positive. I don't know why a learner will do that, because it is clear there it is negative, and then minus into minus 19.84. Then here, yes, the learner will get it as positive, at least here, because the calculation leads to a positive answer. After substitution, if the learner goes straight to the final answer, we can accept, because the calculation, or rather the substitution, leads to a positive answer, then we can accept it. And I want to repeat that and emphasize it, because we have seen many of our learners losing marks because of that. Or if a substitution leads to a negative answer, then the learner must get it as negative first and then interpret it thereafter. So that will be that for question number 3.4.1. Then number 3.4.2. 3.4.2, learners were asked to calculate the loss of kinetic energy of the ball. Remember, the focus is on what? Is on the first bounce. 3.4, the focus is on the first bounce. So we have the marking criteria there, because now we want the loss of kinetic energy. Then the first mark should be on the formula of kinetic energy. Second mark will be on the correct substitution for initial velocity. Third mark will be on the correct substitution to calculate final kinetic energy of the object. And then the fourth mark will be on the calculation of kinetic energy lost. That is the difference there. And then the last mark will be on the correct final answer with the units. So first mark, correct formula, because we are talking of loss of kinetic energy, correct formula for kinetic energy, 1 mark. Correct substitution there. Remember, initial as indicated, initial is 19.84, looking at the first bounce, the one it hits with, 1 mark. Third mark, substitution of the final velocity, the one it leads with, then it will be 11.27 squared. Then the fourth mark on the subtraction of the 2, because you are looking at the loss of energy, of kinetic energy. Then 88, the answer that they will have got here, subtract the answer that they will have got here, that, colleagues, will be 1 mark. And then the final answer indicating what energy loss is equals to 60 joules, then we'll give a mark there. So a learner can end at 60 joules. I think we'll still accept, colleagues. So 1 mark for the formula, 1 mark for first substitution, second mark or third mark for third substitution, fourth mark for the subtraction, and then the last mark it will be on the final answer. I think 3.4.2, it is as clear, or rather it is clear for all of us. Then moving on to question number 3.5. 3.5, here we say using equations of motion only. And it is an instruction that learners use equations of motion. So if a learner does not use equations of motion, colleagues, let us state it now, that learner will get a 0. They must use equations of motion. Then using equations of motion, calculate the maximum speed reached by the ball after the second bounce. After the second bounce. Then we expect the learner to see where the second bounce is and what is happening because of the second bounce. Because after the second, or rather due to second bounce, then the velocity of the object going up is 3.8. And then it goes to the maximum height where velocity, it is 0. And then the If a learner wishes to calculate the time, they can do that, it's okay. But they also need to remember the object diorama that we are dealing with here. It's a projectile. Now the marking criteria is as follows, colleagues. Correct formula to calculate delta y. And if you look at all the options, if a learner uses the correct formula to calculate y, then the learner can get the mark for the formula. Then correct substitution into the formula will have 2 marks for that, 1 mark for correct substitution on the right-hand side and the other one on the left-hand side. Then the correct substitution in the what? In the final answer, will then accept that. So looking at option 1, where down is taken as positive, if a learner chooses to use VF squared is equals to VI squared plus 2A delta Y, will get the mark for that formula. Final velocity is 0, 1 mark, correct substitution on the left-hand side, and correct substitution, the whole substitution on the right-hand side, 1 mark, and then delta Y, that is an upward velocity, upward displacement. And because it is an upward displacement, what I said earlier, then the learner must get this answer as negative first. Then after getting it as negative, then they can then interpret it, we give the mark. But if a learner from substitution goes straight to height is equals to 1.18 meters, then that learner must not get the mark, the final mark, colleagues. Thank you. And then option number 2, we can take down as negative using the same formula. And then formula 1 for correct substitution on the left-hand side, 1 for correct substitution on the right-hand side, and then here the height will be 1.18 meters because we have taken down as positive, as negative here. Then the learner can go straight to the final answer. Here we can accept once a learner has done that. But if a learner uses option 1, then they must get their answer as negative first and then interpret after. Option number 3, they then move on to the formula, which is delta y is equals to VI delta t plus half A delta t squared. If a learner chooses to do that, they must then, using the scale, they must then be able to recognize the point, T2, or how much T2 is. And if they use their scale drawing or their scale correctly, they will then have to see, or the point T2 is equals to 4.3 seconds. Then it means or it took this ball to go to the maximum height after the second bounce, 4.3 minus 3.8 seconds. Then substitution here will be the first part, 1 mark, the second part, correct substitution, 1 mark, and then for option number 3, if we have taken up as positive, first answer must be negative because that displacement is an upward displacement. Then the learner can conclude thereafter and say height is positive 1.98. But if you take down as negative, same thing, the learner will then get a mark for the correct formula. And then the difference here, 4.3 minus 3.8 multiplied by negative 4.8. Negative 4.8. I think this one must not have a negative here. Is it not the same as the first one? Yes. This one must be positive here, and then 9.8 must be negative. So it will be corrected, colleagues. Let me note it. It will be corrected. And then here the answer will be positive, and then the final answer, which is the height, will then be positive 1.18. Fifth option, a learner can choose to use this equation of motion where we have VI plus VF over 2 delta T. Up as positive, we'll have negative 4.8 plus 0 over 2 multiplied by the difference in the points that we have alluded to. And then this should be the answer, negative 1.2. And then we go to 1.2 as the final answer. And then option number 6. Option number 6, same formula, but now down is taken as negative. We'll have first part here, we'll get the mark, for that, and then the difference in the time, 1 mark, and then we'll have the final answer as 1.2 meters. Memalathela, can you please help me with, oh, I've muted, thank you. And then that is question number 3.5. So please note the range, colleagues. We have a range of 1.1 to 1.2 meters on the answer. So accept anything that ranges from 1.1 to 1.2. That is question number 3.5, as I indicated for option number 4. We'll then change here. It must, if we have taken down as negative, then it means already this 4.8 must be positive and 9.8 there must be negative. So we'll correct that in the updated memo. That is that for question number 3.5. We can then move on to question number 3.6. 3.6. Draw the position time graph showing the motion of the ball from time 0 seconds to T2. And then learners were asked to take ground as their reference point and show the maximum height reached by the ball after the second bounce. That is the only thing that we have asked the learners to show in their graph. So for 3.6, we'll take positive marking from 3.5, meaning that height that the learner will have calculated in 3.5. If it is correctly indicated here, then the learner will get a mark. So in terms of the shape, the first part of the motion, colleagues, then this will be the shape up to 1 second. And then the ball spends some time with the ground, and then from T1, it then goes up, and then it goes back to the ground. Then we have the shape, or rather the contact time there. We can see we're at T is equals to 3.8. It then goes in after the second bounce up until T2. They do not have to show T2 as in the values. So let us look at the marking criteria. But in terms of the shape, colleagues, this is how we expect the graph to look like. This is how we expect the graph to look like from 0 to T2. The graph should look like this. Then the marking criteria is as follows. 1 will give the marks for correct labels and units on both axes. So they will indicate position in meters, and they will also indicate time in seconds. If learners have given us the axis and they have correctly labeled them with units, then let us give them 1 mark. Then we look at correct shape from 0 to T1. The first part, if it is there and it is correct, then let us give them 1, colleagues. Then the 2 maximum heights from T1 to T2. If they are shown and they have a decrease in magnitude, the first maximum must be greater than, after the first bounce, must be greater than the second maximum. If a learner has both of them, and then in that, the first maximum is higher than the second maximum. If that is the case, then we can give a mark, colleagues. And the last mark will be correct second maximum indicated. If that 1.8, and if a learner has this second maximum and it is correctly indicated on the position axis, then we can give a mark there. Then things to note, if up is taken as positive, meaning these graphs are then drawn on the positive axis, they are drawn on the positive axis. If that is the case, let us give 3 out of 4, colleagues, so that our learners know, or whenever the graph has been drawn for them, it means direction has been chosen and they must go with that. So if everything is correct, but now up is taken as positive, we subtract 1. And then if ground is not taken as the reference point, maybe the learners take the reference point as the point of projection. If that is the case, but everything else is correct, then colleagues, let us give these learners 3 out of 4. And then in case both notes are applicable, 1, they have taken up as positive 2, they have taken whatever, and most likely the point of projection as the reference point. If both of them are applicable, then the learner will get a maximum mark of what? Of 2 out of 4. That will be question number 3.6, which brings to an end question number 3. Now I'll open for hands, and I would like to recognize Ms. Ngula first. Ms. Ngula, now is your chance to ask ma'am.
And I'm happy if we look at question 3.1, it wants a definition for a projectile. And then according to this memo discussion, they give definition for free fall.
Oh. Okay, Askis, yeah. No, it will be corrected. No, I see it now, ma'am. Thank you very much. It will be corrected, colleagues. Please note that. I'm sorry for that. Yeah, I don't know how we missed it. Thank you very much. Any other hand?
On the chart in Tate, there's a suggestion for 342. They say that they require you to do the positive marking within the question and show the arrows on the updated memo.
Okay, ma'am, thank you very much. That will be done.
And then the other one, it says if the learner wrote down positive and the graph showed that of up is positive, how do I award marks?
The learner wrote positive.
Yes.
Where,
but
ma'am?
Positive down.
The last question.
Yeah.
Okay.
The learner wrote down positive. The learner indicates the down as positive, but what he draws is upward positive. How do you award marks?
No, then we'll go to that that note. When up is taken as positive, the maximum that the learner can get is 3 out of 4.
Thank you, sir.
Okay.
That will be all from the chart.
Okay. I do not see any hands also. I take it our colleagues are okay. The definition there will be corrected, colleagues.
There's a hand.
Okay.
Mwekezi, you can unmute and talk.
Good afternoon.
Afternoon, Minier.
With regard to the 3.2 Minier, what the learner is the gradient of the graph is positive. Instead of the velocity is increasing.
Gradient of the graph is positive. Instead of velocity is increasing.
It's
Yeah, I'm inclined to accept. Yeah. I'll accept, colleagues. Yeah.
thank you, Minier.
Okay.
There are no hands in that you can continue to question 4.
Okay, thank you very much. Question number 4 is on momentum and impulse, colleagues. Before that. 2 trolleys A and B with masses 50 grams and 50 grams respectively are joined together by a compressed spring. The trolleys are moving on a smooth surface with a speed of 2 meters per second in an easterly direction, as shown in the diagram below. We have the 2 trolleys there. And then when the plunger is tapped, the spring is released and sound is produced. Trolley B then continues to move eastward with a velocity of 10 meters per second. So the first question, learners were asked to state the principle of conservation of linear momentum in weights. This will be 2 or 0, colleagues. The total linear momentum of an isolated system remains constant or is conserved 2 or 0. This one we want it as it appears in the examination guideline. Then 4.2 is the explosion taking place during the separation of the trolleys, elastic or inelastic. And then learners were asked to give a reason for the answer. It is inelastic because energy is lost in the form of sound, but that the second part, if it is not there, colleagues, we can give a mark. but let us indicate those types of energies that are there so that learners know or what type of energy here or how was energy lost. So inelastic, energy is lost in the form of sound. Then number 4.3, learners were asked to calculate the velocity of trolley A after the spring has been released. Then here we'll expect the learners to use the principle of conservation of linear momentum. So the first part will be on the principle. Sigma pi is equals to sigma pf. And please let us be careful or the learner shows the subscripts correctly, colleagues. If a learner just writes sigma p is equals to sigma p, then the learner is not talking to the principle. Even if a learner chooses to use maybe the expanded form of this, whereby they will have mass of A plus mass of B multiplied by initial velocity is equals to mass of A multiplied by final velocity of A, and then mass of B multiplied by final velocity of B. The learner must indicate the subscripts because different objects and different variables must be symbolized differently, colleagues. So let us be careful with the symbolization of these variables and objects. If the learner uses that expansion method, it's okay, let them use it, but they must indicate the subscripts correctly. If we have object A or object B, then their masses must be represented differently since we have different masses for the two trolleys. If a learner just writes M1 plus M2 as if the two have got the same magnitude, then the principle will be wrong. So let us penalize for that. And then having said that, or unless the velocity is the same or unless the masses are of equal magnitude, then we can accept the same symbolization. But if they are different, they must be symbolized differently. Then we'll have 1 mark for the principle, 1 mark for correct substitution on the left-hand side, and then 1 mark for correct substitution on the right-hand side, and it must be the whole substitution with the conversion. And then since this substitution for first option leads to a negative answer, then the learner must show the negative answer and then interpret thereafter with the direction, because it is going to it is going west. Option number 2, it is just but a change of signs. Correct principle. The whole substitution on the left-hand side, correct. The whole substitution on the right-hand side, correct. And then the final answer there, 1.2 meters per second to west. But because the substitution here leads to a positive answer, if this is not indicated, then the learner goes straight to the final answer. That we can accept. But here we cannot accept it because the substitution here leads to a negative answer. Then the learner must first show us the negative answer that we'll have got. Thank you very much for question. Oh, yes, thank you very much for question 4.3.1. Then question 4.3.2. Then the learners are asked to calculate the change in momentum of trolley A. Change in momentum for trolley A. The formula for change in with positive marking for 4.3.1. Please note positive marking for 4.3.1. Then we'll have change in momentum is equals to mass into final velocity minus initial velocity. And then for that formula, then the learner will get 1 mark. The whole of the substitution correct, then the learner will get 1 mark. And this substitution, I think here we need another option where we take is as negative like we did in 4.3.1. That will be added, colleagues, in the updated MEMO. So then we'll have, for correct substitution, this leads to a negative answer. The learner must show us a negative answer. And then the final answer for change in momentum will then be 0.6 kilograms meters per second west. That will be 3 marks for 4.3.2. And then, like I indicated, I will also add option number 2 for 4.3.2. Then 4.4, learners are then asked to write down the direction of the change in momentum for trolley A. Then here, because change in momentum for trolley B, Or for trolley A that we have calculated, it is towards, for trolley A that we have calculated, it is towards the west. Then for B, it must be in the opposite direction, which will be east. Okay, so we'll accept that, but let us then apply positive marking, colleagues. If for whatever reason a learner then writes here, changing momentum is west, is east for whatever reason, and then they then use the skill or the knowledge that it must be in an opposite direction, here they write west, then we can accept. Then the next question, colleagues, is question number 4.5. A rock of mass 2.5 grams is dropped from the top of a 3-meter high building. Refer to the diagram below. After reaching the sand ground, the rock does not bounce up and it takes 0.3 seconds to come to rest on the ground. Then ignore the effects of any form of friction. The first question is, while the rock is falling, the earth is not exerting a force on the rock. The learners were asked to comment on the statement as to whether it is true or false. Then that will be false, because there is gravitational force acting on the rock. 1 mark for false. And then 4.5.2, calculate the net force exerted on the rock while it is in contact with the ground. Then we must calculate the net force exerted on the rock while it is in contact with the ground. First thing, colleagues, is to find the velocity with which the rock will hit the ground with, because final velocity will be 0 because it comes to rest after 0.3 seconds. So it reaches with a certain velocity and then it comes to rest after 0.3 seconds. So learners must first find the velocity with which it hits the ground with. And that will be a final velocity for the vertical motion of the object from where it was dropped to the ground. Then learners will then get or use equations of motion to get that final velocity, which will then be 7.668 meters per second. So here we'll just give a mark for correct substitution. Then the formula that leads us to the answer that is asked here is the one that will give the mark 2. Then we'll have a mark for this formula, and then a mark for correct substitution on the left-hand side, a mark for correct substitution on the right-hand side. And because this leads to a negative answer, then the learner must indicate the negative answer first, and then write the final answer, which is 63.9 newtons upwards. Then the 6 marks will be allocated as follows, colleagues. 1 mark in the substitution to find the velocity the rock will hit the ground with. That is where the first mark will be. In the substitution, no mark in the formula to find the velocity the rock will hit the ground with. It is a mark on the substitution. Then we'll have a mark for the formula now that is leading us to the answer that is asked there. So we'll have a 1 mark there. Then we have 1 mark correct substitution on the left-hand side, another mark on the right-hand side, meaning this answer that they will have got here will now become the initial velocity when it hits the ground. Then it must be correctly substituted here. We'll also indicate the arrow for that substitution. And then with option number 1, with down taken as positive, then the answer must be negative first with the correct substitution. Then the learner must indicate this negative answer. Then F net is equal to 63.9 newtons with correct direction. So the answer and direction will be marked independently. That is how the 6 marks will be allocated, colleagues. And then option number 2, still, now we have taken down as negative. The learner must get this answer as negative 7.668 meters per second. Formula mark correct substitution on the left-hand side, correct substitution on the right-hand side, and then final answer with what? With upwards. Here, the substitution leads to a positive answer. Therefore, we can accept it like that, colleagues. I'll be emphasizing that point as we move because it is something that many of our learners lost marks when we were marking last year. So please let us be careful of that. Then that will be the 6 marks for 4.5.2, which then brings to a conclusion the discussion for question number 3. Now for question number 4. Now I'll open for any clarity seeking questions, colleagues. Is there
there's no hand, but on 3.2, it says, I have a 3.2, ne? I have a learner that said the projectile did not reach the maximum height. Do you give or not for 3.2?
Oh, that one as to whether it goes to the ground.
Yes.
Not reach maximum height.
Yes.
Yes. The learner is correct, but not correct. It did not reach the maximum height. That learner is not wrong, but is the answer relevant to our question? That is my worry. Yeah.
What leads to the learner, the object not reaching the maximum height?
Exactly.
So
Let us not give, colleagues.
okay, that is the only thing on the chart. So we can move on to question 5. There are no hands.
Okay. No, thank you very much, colleagues. I think we are moving very, very good. Question 5, that is on work, energy, and power. So the first, let me read the statement first. The diagram below shows a man with a mass of 75 kilograms standing on the top of a building that is 18 meters high. The man jumps to the ground. And then learners were told to ignore the effects of air resistance. Then we can see, or we expect the learners to have seen that man jumping to the ground there. The first question, 5.1.1, state the principle of conservation of mechanical energy in waves. The total mechanical energy or the sum of gravitational potential energy and kinetic energy in an isolated system remains constant. That, colleagues, will be 2 or 0. And please note where 2 or 0 is applicable and where this thing of context is applicable. So for this one, it is 2 or 0. A learner must give everything correct. Then 5.1.2, learners were then asked to calculate the speed of the man as he lands on the ground. So we expect here the learner to use the principle of conservation of mechanical energy, where we'll have Emec at the top and being equal to Emec at the bottom, with the application or a substitution there. 75 times 9.8 multiplied by 19 on potential gravitational potential energy plus half multiplied by 75, 0, because the man jumps from there where initial velocity is equals to 0, or rather velocity is equals to 0 at the top. And then we'll have 75 times 9.8 times 0 on the ground. The height is 0. And then half times 75 times v squared. That is the velocity or the speed the man will hit the ground with, or will land at the ground with. Then the answer we are expecting there is 18.78 meters per second. So the allocation of the mark, correct principle, 1 mark. And the learner can't just write Emec is equals to Emec. It must be Emec at the top, is equals to Emec or on the ground. But Emec is equals to Emec. Maybe colleagues will advise there because it's the same, that one. I think that one maybe we can just accept because it is the same mechanical energy. Okay, yeah, here I think we can then accept. And then we'll then have this substitution on the left-hand side and another substitution on the right-hand side. And then the final answer will be 18.78 meters per second. Then that is where the 4th mark will be. You are noted, Marlene, will give you a chance. And then question number 5.1.3, The man bends his knees as he lands on the ground. The man bends his knees as he lands on the ground. Lincoln, you are also noted. Then the question says, give a reason for this action referring to a relevant law of physics. So here we are expecting a learner to refer to Newton's second law in terms of momentum. So we know that bending the knees increases the contact time or time it takes to come to rest. That is the first thing that we expect the learner to recognize. Or as you land on the ground, we bend the knee. Purpose unwittingly is to increase the time it takes to come to rest. And according to the formula, F net is equals to delta P over delta T for constant change in momentum. If that change in time increases, then F net decreases. And then this will lead to reduced chances of serious injuries. So 1 mark for indicating what does bending of knees does. It increases the contact time or time to come to rest. And then referring to the formula or the physics law or physics principle that they use at constant change in P, if this increases, then F net will decrease. So the first mark is reference to the formula and stating for constant change in momentum. And then the third mark is where a learner will indicate the relationship between change in time and the net force that the person or the man will experience as he lands on the ground. So that is how the 3 marks will be allocated, colleagues. And then 5.2.2, the simplified diagram below shows a slide ABC at the playground with the sides as shown. The box of mass 400 kilograms is pulled down the slide AB from rest at post A all the way to point B by tension T of magnitude 200 newtons. The kinetic frictional force experienced by the box as it moves from A to B is 848.71 newtons. Then the first question after the statement, that is 5.2.1, learners were asked to state work energy theorem. Here we have that marking criteria of context, colleagues. The net work done on an object is equal to the change in object's kinetic energy. And I think the change must also be there as the phrases are important. So here, if any of the underlined phrases or weight is omitted in correct context, then we'll subtract 1. So the learner can say the net work done on an object is equal to the object's change in kinetic energy. Then a learner will get 2 marks. Let's say, for instance, if a learner just says the net work done on an object is equal to change in object kinetic energy without that change, I think that one is where a learner will forfeit 1 mark and get 1 mark. That is how we'll then calculate. They will not calculate, mark this question. Or a learner can state it by saying the work done on an object by the net force is equal to the change, or is there, is equal to the change in object kinetic energy. The learner will get 2. Omission of 1 phrase or weight in correct context. In correct context. If it is not there, then a learner can get 1 out of 2. That is for 5.2.1. Or the change is there is equal to the change. Yes, it is underlined. I was looking at this one, but then this one, I was looking at this, but I can see already the change is there and it is underlined. It is one of the keywords that the learner must show in their definition. Then 5.2.2, draw a free body diagram showing only the conservative force acting on the box as it slides from A to B. The only conservative force is gravitational force, colleagues. It is gravitational force. So this is the free body diagram that we're expecting. The acceptable labels will be as given there. Fg, small letter w, or the magnitude of the gravitational force there. Any one of them will be accepted, 1 mark. And we know the criteria for marking a free body diagram. For any extra force, we subtract 1. Okay. Let us then move on to question 5.2.3. Using energy principles only. Here, learners must use energy principles. Using energy principles only, learners were asked to calculate the speed of the box when it reaches point B. When it reaches point B. If we were to draw a free body diagram, especially showing the forces acting parallel to the inclined colleagues, will recognize that acting on the box as it moves down the incline will be the tension force, Fg parallel, and frictional force. So for option, learners can use work energy theorem. And then when they use work energy theorem, they must then have work done by tension, they must have work done by friction, they must have work done by Fg parallel. And then on this other side, they will have half change kinetic energy, that will be half m velocity at point B squared minus velocity at point A squared. So how then do we allocate the marks? 1 mark for the correct principle, energy principle, 1 mark for correctly substituting into work done by tension, 1 mark for correctly substituting into work done by friction, and then 1 mark for correctly substituting into work done by Fg parallel. Then 1 mark for correctly substituting into change in kinetic energy. And then the speed at point B must be 4,44 meters per second. That is option 1, where a learner can use work energy theorem. Then option 2, a learner can use work done by non-conservative forces. And then the non-conservative forces that are acting on an object as it moves from point A to point B are tension and frictional force. So we'll then have 1 mark for the correct principle. WNC is equals to change in kinetic energy plus change in gravitational potential energy. And then 1 mark for correct substitution into work done by tension. 1 mark for correct substitution into work done by friction. And then 1 mark for correct substitution into change in kinetic energy, and 1 mark for correct substitution into change in gravitational potential energy. And then the last mark will be on the final answer. That is how for option 1 and option 2, colleagues will allocate the 6 marks. Okay, and then 5.2.4. Now learners were calculate the average power delivered by tension to move the box from A to B. So the average power will take positive marking from question 5.2.3. Since this is not moving at constant velocity, learners must then note, or they need to add the velocity there, and then by the number of velocities that they have, which is initial 0 and then final 4,44 from the previous question, and then they divide by 2. So the formula for correct for average power, 1 mark. Strain of the friction, 1 mark. And then calculation of average speed, 1 mark. And then the final answer, average power, is 444 or 444 watts, 1 mark. That is the allocation of the 4 marks for our learners, colleagues. Then we have decided to accept, even though we asked specifically for average power, but we can accept if a learner uses that general formula for power, which will be P equals to WT over delta T, but it will then mean, or a learner will then have to calculate time using the values that they have. Currently, they have the displacement, which is 3. They have initial velocity and final velocity. And then with that, they can then be able to calculate the time. So with that after calculating the time and substituting it correctly here, then we can accept this option. So it will be 1 for formula, 1 for work done by tension, 1 for correct time calculated here, and then 1 mark for the final answer, which is 444 watts. That is how the 4 marks will be allocated for question 5.2.4. And the last question, how will the work done by weight on the box compare if the box takes path AC instead of path AB to get to the ground? Write down only greater than, smaller than, or equal to. Gravitational force is a conservative force, then work done by it is independent of the path taken. So the answer and the only correct answer here will be equal to. That is that for question number 5. Let me start, Mema Lashela, if you allow me to start first by recognizing Marlene.
Hello, sir. Hello, colleagues. I have got 2 questions, please. For question 5.2.3.
Okay.
I would like to know there if we can accept that if the learners only calculate work done by gravitational force and not the parallel component.
Yeah, we can accept.
All right.
Because if
And
you look
then-
at, if we look at it,
Yeah.
you see this 3 cancels that 3, né?
Yes.
Then we are left with 1.5 here, which then becomes work done by gravitational force. Yes, we can accept, ma'am.
All right. And then I would like to discuss question 5.1.2. In question 5.1, they specifically state that the man jumps to the. For me, the fact that the man is jumping indicates that there is an initial velocity. If he fell to the ground, then the initial velocity had. But the fact they say if he jumped, to me, implies that there has to be an initial velocity. So 5.1.2 for me is not something that is possible to calculate because we cannot assume that the initial velocity is 0.
Yeah, you are bringing something. Okay, the man jumps and can't jump with 0. There has to be initial velocity. Yeah. Colleagues, what do you think? I think it's an oversight. Any comment on that, colleagues? But I think she has a point, no? Mema Lashela?
Initial. Ntate Mohapi, I agree with Marlene because we cannot substitute initial velocity as 0. So we'll have to take out that 4 marks. That is my suggestion.
Okay. Any other comment, colleagues? I think I'm inclined to agree with Marlene. And I suspect we have a lot of learners who got that 4. But it is a correct, and then the language also indicates there has to be initial velocity. It will then mean this cannot be, we'll then have to take out that 4 marks. Okay. Any comment? Is there any other person?
We have Ntate Mokoena. Ntate Mokoena, unmute yourself.
Thank you, Mema. No, I don't know if taking it out. Okay, no, I just saw a line there. Ignore the effect of fraction. So yes, okay, colleagues, no, it's fine.
Okay. I know it's fine.
Okay. Yes, and Ntate Mohapi, we have, they said there was no instruction that indicates the learners must use the principle of energies only in this question. So if the learners uses the equations of motion, do you advance or penalize?
5.1.2.
Yes.
Now is now
No, not
immaterial.
for, this is the only calculation in this question. And then at 4.2, they say kinetic energy is not conserved at 4.2.
Where are we, Mema Lashela? Which question?
512. I can read,
Yeah.
you just took out that question. So that
So
equation of
immediately
motion
after
is
the other
out.
one, okay, fine.
I was reading what is here. And then at question, can we go to question 4?
Mhm.
And then question 4, let me start with 4.2. 4.2, they say kinetic energy is not conserved. The learner wrote kinetic energy is not conserved instead of energy is lost. So that is which is a definition here in elastic.
Mm. But how do we know? Because here we are told about, let's accept, because we are told about sound, okay? Not let's accept, man. Mm.
And then
Because it's from the
question
definition,
4.3.
elastic and inelastic, yeah.
Yes.
I mean,
Sorry, ma'am, let me finish here. 431, they say if the learner did not convert masses to kilograms, but the answer is the same as in the memo, we award full marks.
No.
So 431 is no, and then
So the
4.3,
learner will just get 1 mark because substitution will be wrong. And once substitutions are wrong, colleagues, remember the final answer is wrong.
so the learner might get the mark for the formula only.
Yeah.
Okay. Then Ostrich put question marks, I don't know, on the chat, or if she can unmute herself and then say what she wanted to say. Or she is sorted. I hear there's someone who did not raise their hand, but she is speaking. I will give him the chance to talk.
okay, it's about 5.1.2. I also had the same sentiment that there was no initial velocity there to be substituted. However, it resolved at 5.1.2.
Okay.
Okay,
No,
so the
thank you.
question is
Thank you.
faulty.
Mhm.
So
No,
which
thank you very
means-
much. Yeah.
Okay, so that then, so this question is faulty, it is out. So the learners will be marked out of 146.
Yes. We'll
Okay.
mark out of. Yeah, but let us wait. I just hope there aren't any.
Okay,
Yeah.
no, for now, it's minus
For now,
4.
yeah.
Yes, okay.
Okay.
You can continue that there are no hands to question
Okay.
6.
Then, colleagues, let us move on to question number 6. Né? Question number 6. Douglas effect. An ambulance emits sound waves of wavelength 0.5 meters. An observer standing on the side of the road to record sound waves with a wavelength of, or with the wavelength that is 10% longer than the wavelength of the emitted sound, which means the detected wavelength is greater than the emitted wavelength. Then take the speed of sound in as 340, and then the first state Douglas effect in weights. Here, the marking criteria is there. You subtract 1 if any of the underlined weights or phrases is omitted. Then we expect learners to state Douglas effect as a change in the frequency of sound detected by the listener, because the source and the listener have different velocities relative to the medium of sound propagation. So we'll then have to check if any of the underlined weights is omitted or phrases is omitted, but the context is still correct, then we can give 1 out of 2. But if the context is lost due to omission of that weight or that phrase, then the learner will get 0. We'll then also accept if a learner writes the change in frequency or pitch of sound detected by the listener due to relative motion between the sound source and the listener. That we can also accept as the definition for Douglas effect, colleagues. Then 6.2 is the ambulance moving towards or away from the observer. As indicated earlier, the observed wavelength is longer than the emitted or the actual wavelength, which then means, sorry, the ambulance is moving away. Then the response or the explanation there can be with reference to the wavelength or the frequency. Whichever one the learner chooses to use will be acceptable. So the observed wavelength is longer than the actual wavelength, or the observed frequency is smaller than the actual frequency. Then it will be one for away, and then one for explanation. And the reference will or must either be to the wavelength or to the frequency, the comparison thereof. Then number 6.3, calculate 6.3.1, the frequency of sound emitted by the by the ambulance. We have by the ambulance, we have the wavelength of those sound waves. Then we can then find the frequency. 1 mark for the formula, 1 mark for the whole of the substitution, and 1 mark for the frequency, which is 680 Hertz. So that is how the 3 marks will be like, colleagues. I don't think we need any clarity on this one, straightforward as that. Then 6.3.2, the magnitude of the velocity of the ambulance. So we'll then take positive marking from question 6.3.1. So with that, colleagues, then the learners are expected to use Doppler's effect formula. And then after that, they will then substitute relating the differences in the frequencies of the observed frequency and the actual frequency, and then with the movement either towards or away. Then formula, 1 mark, substitution on the left-hand side, that is the frequency of the listener. Substitution thereof, remember, it must be less than that. It must be less than 680. And then substitution on the first part here, 340 over 340 plus VS, 1 mark, and 680. And the speed of the source or the ambulance can be 37.78 meters per second. Or a learner can use an interpreted formula there. Remember, we do not accept if a learner writes maybe V plus VL. Again, if the learner chooses to interpret the signs and not give us this, then he or she must interpret everything. Then in the interpretation, we'll have FL is equals to V over V plus VS, and then we'll get the answer. So 1 mark for correct formula, 1 mark for correct substitution on the left-hand side, 2 marks on the right-hand side. The first mark will be on the actual frequency first only, taking from 6.3.1, and then the other mark will be on the substitution there of the velocities or the speeds, and then the final answer, speed of the source being 37.8 meters per. Diagram 1 represents the spectrum of the same element in the laboratory on Earth. Diagram 2 represents the spectrum of the same element from a distant star. Then the question is to the learner 6.4.1, from the observation made in the 2 diagrams, can it be concluded that the universe is expanding? Chiral redshift is the one that indicates that the universe is expanding. Then because the spectral lines have shifted towards the red end from diagram 1 to diagram 2, then the conclusion can be made that yes, the universe is expanding. So 6.4.1, yes, 1 mark. Then 6.4.2 for 3 marks. Learners are then asked to explain the answer to 6.4.1. First point, learners must refer to the movement of the spectral lines. Point number 2, then they must refer to whether that end or the movement is it towards longer wavelength or shorter wavelength, or towards higher frequency or smaller frequency. And then number 3, then learners must refer to Doppler's effect and indicate that that movement, then what does it mean in terms of Doppler's effect? So first point, spectral lines are redshifted from diagram 1 to diagram 2, and then or shifted towards the red end of the spectral lines. So here we talk to the observation, which is the movement of the spectral lines, 1 mark. And that is the end of longer wavelength or smaller frequency, 1 mark. And according to Doppler's effect, if the observed frequency decreases, then the distant star is moving away. Then that will be the third mark on this question. And then if that is the case, if the distance star is moving away, it means that the universe is expanding. So we don't have the mark for the universe is expanding. We'll get the mark, first mark, learner must refer to the movement of the spectral lines. Second mark, a learner must refer to longer wavelength or smaller frequency. Third mark, a learner must refer to Douglas effect and its relation to the decrease in frequency. And what does it mean in terms of the movement of the objects or a movement of either the listener or the source. That is how colleagues will allocate the marks for question number 6.4.2. And then that brings to an end question number 6.
Thank you, Tate Mohapi. We have a hand from Marlene. Over to Marlene.
Thank you, ma'am. I would like to ask for question 6.3.2. Are we going to consider positive marking from 6.2 since the learners, if they incorrectly identify towards instead of moving away, but then use the correct signs in 6.3.2? That's the first question. And then secondly, if you calculate the 680, the 90%, the shorter frequency of the lower frequency is not the same as the longer wavelength. So they first will have to calculate the longer wavelength and then convert that to a frequency. Otherwise, the math does not work out.
Okay. The issue of 10% and percent does not work here. We'll have to calculate
Yes, so they first have to calculate the 10% longer wavelength and then convert that to frequency. Using the same principle as in 6.3.1. Otherwise, because the frequency that they actually then get for the listener is 618 instead of that which we have calculated in the question.
Okay, and that will lead to a different answer, ne?
Yes.
Okay. No, I'll have a look. I think we took it from face value that 10% will be equivalent to 90% on the other side of the frequency, but we'll make calculation and look at it, man. Yeah, it's okay. 6.2 to 6.3.2. Yeah, but I think we can accept because the skill is correct.
Thank you very much, sir. I appreciate it.
Yeah, because the learner has applied the correct skill.
I did not get what was the suggestion with the positive marking. I heard something about it. What did they say?
For 6.2, for 6.2 to 6.3.2, like if a learner then says away, instead of away, they say towards. And then they use that towards correctly in 6.3.2. Isn't it the correct application of the skill?
It is correct, but you're going to mark it independently. Because if you have to start doing that here, then we'll have to go back to other questions whereby we'll have to apply the same positive marking. So we'll apply, we won't apply that positive marking from 6.2.
No, okay. Well, okay. No, it's fine, it's fine. It's fine.
Then we have Ingrid Extian. Ingrid, unmute yourself.
Good day, sir, and Emma. I agree with Marlene. I also wanted to ask that because if you calculate the 10% longer wavelength, then it gives you 0.55. And then, like Marlene also said, that then it gives you 618.18. So if you use that thing, then you get to the answer of 34.001 meters per second. So that that is then the
Ingrid, can you take a picture of that calculation and send it to us? Then we'll share it with Tate Mohapi.
Okay, I will do that, ma'am.
All right. No, thank you very much.
Thank you.
And Tate Mohapi, no, we don't have hands. We don't have anything on the chart. I think we can move on to question 7.
Okay. Colleagues, let us move on to question number 7. question number 7, we have Coulomb's law or electrostatics. There we have two charges P and Q with magnitudes, -3 and -3, which exert an electrostatic force on each other. There is a gravitational force Fg that exists between the centers of the two charges. The distance between the charges is given there as 1 × 10⁻⁹. Then the first question is the gravitational force Fg between two charges a force of attraction or repulsion? Then learners must name the law they used to justify the answer. We know gravitational force, colleagues, it is an attraction force. And the law that we use to justify this answer is universal law of gravitation, Newton's law of universal gravitation. Each particle attracts any other particle. Then number 7.2, learners were then asked to state Coulomb's law, the same principle that we have been using. Context, very, very important. Omission of any word or phrase in correct context, then a learner can get the 1. But if the context is lost in the omission, then the learner will get 0. So the magnitude of the electrostatic force exerted by 1 point charge on another point charge is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. And then that will be 2 marks. Then number 7.3, in which direction, left or right, is the electrostatic force experienced by charge P due to Q? Then the answer should be left. And then that will then be 1 mark for that. 7.4, draw the resultant electric field pattern due to charges P and Q for 3 marks. And then this is the marking criteria, or rather the diagram. Colleagues, we are expecting something like this one that we have there in the marking guideline. And then the marking criteria is correct direction of the field lines. And remember, arrows must be shown on each and every field. And then the field lines do not cross each other and do not touch each other. That will be the 3rd mark. And then we have a correct shape. Remember, it is only these ones that are directly opposite that will be straight. And all other field lines, they must bend. They must bend. And these are things that we must indicate to our learners. And then here we are dealing with negative charges, which means then the field lines must move into the charge. They must move into the charge, and then in all other ones, except the ones that are directly opposite, except these ones that are directly opposite, they must bend. They must show a bit of a bend there. We can't have all of them straight line there at the back. Only this one that is directly opposite that will be straight, and all the ones will have to bend. And that is the marking criteria for 7.4. 7.5.1, calculate the magnitude of the electrostatic force, Fe between P and Q. We have Fe is equal to KQ1 Q2 over R squared. And then that will be electrostatic force formula. And then we'll then have the substitution thereof. And then the answer, which is 8.1 × 10⁻10 newtons. If a learner has done that correctly, let us give that learner 1 mark. All the marks, colleagues. 1 mark for the formula, correct substitution, the whole substitution, 1 mark, and the final answer will be 1 mark. 7.5.2, electric field strength due to P at point X, which is 5 × 10⁻⁻10 meters to the right of charge Q. So we can see where point X is, colleagues. Now we want electric field strength at point X due to P. So the formula for electric field strength is given there. And then when you do the calculation, the distance between P and point X will be 1 times 10 to the power negative 9 plus 5 times 10 to the power negative 10, the sum thereof. And then the electric field strength must then lead us to 1,08 times 10 to the power 10 newtons per coulomb with direction. Here we did not ask for magnitude, we wanted electric field strength. So learners must give us the magnitude and direction. So it will be 1 mark for the formula, 1 mark for substitution, the whole substitution, and then 1 mark for the final answer and direction. And that will be that for question number 7. That will be that for question number 7. And then with that, I do not know. I see one hand. Marlene? Yes.
Hello,
Marlene?
sir. I'm at 7.5.2. I agree with the formula and the substitution, but I do not agree with the answer there. For me, the answer is 1.2 times 10 to the power 19 Newton per Coulomb to the left, and not the 1.08 times 10 to the power 10.
Okay, no, we'll just verify. Okay, it's not a problem. We'll just verify, colleagues, and then it will come with the updated memo. Okay. Thank you very much, Marlene. You can lower your hand.
Yes, I'm happy. Question 7.1.
7.1, okay.
November says, if the learner wrote repulsion, Newton's law of universal gravitation, can I mark independently?
No.
So you apply positive mark, negative marking
Negative,
on
yeah.
7.1. So
Yeah.
just, okay,
Indicate. I will indicate here.
okay. Thank
Okay.
you. Okay, we can move on to question 8. There are no hands, there are no
Okay.
comments. Thank you.
All right, thank you very much. Then we can move on to the last question, colleagues. We can move on to the last question 8. It is based on electric circuits. So here we have a diagram below showing a circuit with a battery of EMF of 12 volts and internal resistance of 1 ohm and external resistors R1 and R2 of 10 ohms and R3 and R4 with the same resistance X that we do not know. Then we have the circuit diagram. It is indicated there. Learners must be aware of it or be able to analyze it. Then 8.1, learners were then asked to state Ohm's law in weights. Learners were then asked to state Ohm's law in weights. Here, 2 or 0, colleagues. No issue with the context. We want learners to state this as appears in the examination guideline. The potential difference across a conductor is directly proportional to the current in a conductor at constant temperature. 8.2, will the reading, or will there be a reading ammeter A1 with switch S open? With switch S open, will that reading on A1, looking at the position of A1, then the answer must be yes, because this is a complete or a closed circuit with a battery allowing the current through A1. The current will keep that part of R3 and R4 and then go on to move through R1 and R2 and then go to A1. So the answer here should be yes. That's a complete, I will just put an OR there, or a closed circuit with the battery allowing current to pass through A1. Then 8.3, switch S is now closed. The total external resistance of the circuit is 2,2222 ohms. Then 8.3.1, learners were asked as to whether after the closure of this switch, will the battery become hotter or colder? Talks to the temperature, whether the temperature of the battery, will it increase or decrease with that. When that happens, colleagues, we know it is the same as 18 resistors in parallel, then total external resistance will decrease. And when total external resistance decreases, total current will increase. And when total current increases, then the energy of the battery will then increase, which then means or this thing will become, or the battery will become hotter. 8.3.2, calculate the resistance of R4. Learners were given the total external resistance and the external resistance 2,2222 ohm. And then the formula of calculating R parallel, if a learner has written that correctly, they will get 1 mark. Substitution of the external, because all the resistors there are parallel, we have 3 parallel branches there, then it will be 1 over 2,222. I think we have a missing 2 in the substitution here. We'll then show it, because in the question we have 4 2's after the comma. We'll then include it there. And then we'll have correct substitution in the whole substitution on the right-hand side. And with that, we must end up with the correct answer for resistor X, or resistance of resistor 4 as 2 ohms. There is a missing 2 here. I will then include it in the updated memo, colleagues. Then just take note of that. And then if the learner has written the correct formula to calculate R parallel, 1 mark. Correct substitution on the left-hand side, 1 mark. The whole substitution on the right-hand side, 1 mark. And then final answer of 2 ohms, then will be the 4th mark. Then number B, that is 8.3.2b, calculate the reading on the ammeter. And with the position of the ammeter, it does not read the total current. The ammeter A1 does not read the total current moving in the circuit with S closed. With S open, yes, it was reading the total current, but now with S closed, it is not reading the total current. Then the approach we expect from learners is they must first calculate the total current. And after calculating the total current, they must realize the current that will be read by A1 will be the current that will be going through R1 and R2. So what we need to then find is total current using the formula E is equals to I into R external plus internal resistance. We can have 1 mark there, and then we can then have a mark for the whole substitution, which will then lead to learners getting the total current of the circuit. That will be the first part. Notes are not aware of any other approach to this, but learners must get I total first. Then in the I total, for form that I total and the substitution into that formula, then the learner will get 2 marks, 1 mark on the formula and 1 mark in substitution to get I total first. Then after getting I total, we have 2 options that the learner can follow. Option 1, the learner can calculate V external. And then with V external, then the learner will then calculate the current that will go through R1 or R2. But learners must note, must note that A measures the current that moved between R1 and R2, the sum thereof. So after getting the V external, then the learners can use that V external to get the current that goes through either one of them. Then they take R1, because R1 and R2 are connected in parallel, they will have the same potential difference. Then with that potential difference, they will get the current that will be moving 10 or R1 alone. Then after that, they then have to multiply that current in R1 by 2, because that current will be the same as the current that will be moving through R2. And when you do that, you multiply by 2 or you add the 2, then it must lead to current moving through A1 as 1,66 amperes. That is one approach, colleagues. And then the other approach will be, after getting the total current, but learners must get V external. After getting V external, then you can find the current that will be going through R3 and R4. That is current through this R3 or R4. What we know is that the total current minus the current that will have gone through A1, or rather the current that goes through A1 will be equal to the total current minus the current that will have gone through R3 and R4. So the learners can choose that approach is okay. But that will then require us to apply positive marking for question 3.2a, where we found the value of X. Then learners will then find the V external, which is the parallel combination, and then the resistance for the parallel connection or parallel branch there will be 4. With that, then they will get 3,07 amperes as the current that goes through 4 and 3. Then they will then have to remember the one that goes through A1 will be total that they will have calculated here, minus the one that goes through 4 and 3. And with that, they must get 1,66. So we have a range there, colleagues, because of multiple calculations. Let us accept anything between 1.64 amperes to 1.67 amperes for both options, colleagues. These are the only options that we have now. Please share with your subject advisors. I suspect we might have a lot more options to this question. Please share with the subject advisors so that they be included in the updated MEMO. But for now, these are the options that we have, and this is at least the answer that you must get. If you get this answer 1,66, just go through the workings of the learner and then take the picture and share with your subject advisor so that it then be included in the final or updated MEMO codex. That is the marking guideline for question number 8.3.2b. Then the last one. A 2 kilowatt electric heater is used in a household. The heater is switched on for 3 hours per day during June month. The cost of electricity from a municipality is R4.45 a kilowatt hour. June month, then we expect the learners to know in June we have about 30 days. And I don't know any other June with a different day in South Africa, or with a different number of days. So here, then we then ask the learners to then calculate the cost of electricity to operate, for operating the heater for 30 days. Maybe we should have excluded that 30 days because learners must know June has 30 days, but it's okay. Then the cost of electricity will not have a mark on the formula. Then we'll have a mark on the power multiplied by the time, which will be 2 times 3 times 30. That part alone will be a mark, multiplied by the tariff, which is R4.45. That part alone will be a mark. And then the cost of operating electricity, colleagues, that is how expensive electricity is. The cost of operating that for 3 hours, 30 days is 801 rand. And that will be that for question number 8. I would like to open these colleagues for any clarity seeking questions and comments on any other question, because now we have come to a close of our marking guideline session. And before we put the session, any other question? Just
And Tate Mokoena just raised his hand now. Over to you, Tabo.
With question 8.2, if a learner wrote, there are multiple for correct.
Tate Mokoena, we can't hear you. Please raise your voice.
So I was asking if we say if a learner writes there are multiple paths for current flow, can we accept that as a reason?
yeah, but then what is there a reference to it passing through A? Those multiple paths available. Is there any reference to any of those multiple paths having A1 as part of that path?
I don't know if I'm understanding your question, Minya.
Yeah, what I'm saying is a learner in their explanation must make reference to a path having A1 as part of the path. You get what I'm saying now?
Yeah.
Yes, because now saying there are multiple paths and then no reference to the connection of A1, which will then has to be part of those paths, and it will not be correct. So reference to the path having A1 must be there.
So they must be specific. If question said, will there be a reading on Ameta A1, and then they said yes, and they say a multiple paths.
Yeah, I think so, Minirman. Yeah, no, they have to be, Minir. Nah, they have to be. They have to be. What do you think? You think we are being hatched?
Yes, Minir, because
A1 is referred to in the question.
Yes, and also in the diagram, the multiple paths would Elena is interpreting as though because there's an open switch, current is not flowing there, but the other two paths current is flowing.
Hey, okay. Yeah, no, I hear you, Minir. Yeah, no, I think let us accept it's okay.
Thank you, Minir.
Thank you, Minir.
We have Ingrid next year. At the November after
No, ma'am.
Ingrid.
No, ma'am. My light came on. I saw the light, so I'm fine now. Thank you.
Okay. Thank you.
At the November.
Good evening. Good evening. I just want to put the learner reason it is saying Ameta A1 reads the current in resistor 2 and 1. When opening switch S, it will destroy resistor 4 and resistor 3, which are not connected to A1.
It will do what? It will destroy them.
Yes, when you open switch S, it will destroy R4 and R3, which are not connected to A1. Meaning he started by saying Ameta A1, it will read the current through resistor 2 and 1 only. Okay. But when you open switch S, meaning R4 and R3 will no longer be existing, and they are not connected to A1. That's the reason of the
Yeah. No, that learner understands the circuits. Yeah, I think we can accept. I'm just worried with the use of the words Bogma destroy and all that. But then it's okay. I think the learner understands what we are talking about, Mineria. No, let's accept. Okay, you can that in November.
Lower your hand.
Lower your hand, Mineria.
And
Let-
Dr. Mohapi, there is nothing. There was a suggestion in the chat, so I asked Dr. Tekiso to send it directly to you
Okay.
for amendment, yes. And then in the absence of,
Before we
comment,
close, ma'am,
then we can close.
okay. I want us colleagues to come back to question 6.3.1 while we are still together so that we agree. Ne? So 6.3.2, we said the calculation is not, it does not lead to the 90% that we have here. I just want that to check with colleagues if, how is that consistent with the fact that the two are inversely proportional? Doesn't it mean, hooray, when this one increases with this factor, that one must decrease with a certain factor, or that thing does not work with the percentages? I just wanted to check colleagues because I think that is where the thinking was from. Or if a learner takes the fact that the frequency and the wavelength in the same medium, they are inversely proportional. Then when this one increases by this one will increase by the opposite of that. And if that learner then uses that logic, then they will come to this. So basically my question is, can we still accept this one together with that other one, taking into consideration the directly proportional and inversely proportional, or that will then be misleading total? I just wanted to check with colleagues whilst we are still here. I think it was a question that was raised by Marlene, if she's still around.
Hello, sir.
Okay.
Yes, I am still here.
Okay.
I hear what you are saying, but for me, it is a mathematical principle. So, if the calculation is completely incorrect, but it will definitely advantage our learners if we work with the fact that if the one increases with the 10%, the other one will decrease with 10%. So it will definitely be advantageous to the learners. But I do not agree with the math, obviously.
Yeah. Okay. Colleagues, what do you think? Any comment on that? We accept it, but we teach it correctly. Yeah, because now it has that thing of them being inversely proportional. Ne? So what's your view?
And I hope I'm now audible.
Yeah, you are.
All right, thank you. Just with what Ingrid is actually saying, in terms of calculation, mathematical skills are not agreeing, because if we were to calculate the new wavelength, we were going to get that 0.55 meters, as Ingrid has correctly said, and we could have used that speed formula to calculate our new frequency, using that, then we were going to get 618. But currently, with our 600, with our 90% here, we are getting 612. So I don't hear what it means, but it seems like the fact that this type of an increase was an additional one. It was not the multiplying and the dividing. Then that change that we are talking about can no longer be inversely proportional. So I suggest that we rather calculate our 0.55, then use that calculation, the method of calculating in the 631 to get to our 618 and then put it there.
Yeah. Okay, no, I hear colleagues, unless there is any other colleague with a comment, but then I think now the 5 marks will not be appropriate for that question. Elena will have to work a little bit more. So I'm thinking, then the 5 marks, is it still appropriate, Marlene?
So can I then maybe suggest the 4 marks that we then lost for question 5.1.2 maybe redistributed in a way in question 6.3.2?
Yeah, maybe we can get two there, and then the one we'll see where we distribute it. Okay, thank you very much. Yeah, I think we'll distribute it. Then we'll have 7 marks for 6.3.2 colleagues. Né? The 2 marks will be on the calculation of the new FL. And then the other 2 marks will then distribute. Just be on the lookout on the updated memo as it will come, so that we keep the total as 150. Okay. That is that, colleagues. Just remember to fill in the attendance register, and good luck with your ma'am.
I suggest that when you submit the updated memo, just indicate on the cover page or there is an updated memo.
Okay.
Because we are,
Alright.
we are here at the moderation, and then we are struggling with which memo was updated, which one was not updated.
Okay, okay. Now we will indicate, and colleagues, let us use the updated memo, please, when we mark. Once you have marked with the original one, please go back to the scripts and update the marquee with the new one. We'll indicate, we'll also highlight where the marks have been transferred to. I think, Mema Lasela, now we can close the meeting. I don't see any other hands. Yeah. No, thank you very much, colleagues, for being here. I know Friday can be a very hectic day for many of us, worst Friday of a month end, but you chose to be here, colleagues, and we really appreciate you being here. No, it's a month end. For us teachers, it's a month end.
There's a hand from Tatemukwena.
Hey, Tatemukwena, we close. Hey, Tatemukwena doesn't want us
And
to leave.
he's the only one who's left in the chat.
Okay, Mr. Mukwe. Mr. Mukwena. Come in, Mr. Mukwe.
I think that you can close the meeting.
All right. Now, thank you very much, and good luck with the marking, colleagues. Remember, on Monday, we'll be having the second paper memo discussions. Thank you very much, and good luck. The updated memo, I will try and ensure that it is distributed today, later today. Now, thank you very much. Bye-bye.
Bye.